Okay, so now let's take a look at our next unit, looking for Pythagoras. And in our first investigation, we're going to be studying these things called coordinate grids. And if you haven't already, go ahead and read the introduction here. It's really important because remember, our story in this case is looking at the idea of a city plan. And we're looking here at the U.S. Capitol. And the important things to understand in answering these questions right here, that the capital is the origin. So the origin is defined by where you have a plain space, like let's say this space right here, and I want to divide that space up into 4 quadrants. So here's quadrant 1, quadrant 2, quadrant 3, quadrant 4. So make sure you jot that down in your notes in case that ever comes up. But the capital is at the origin. So right there, that is 0, 0, which we refer to as the origin. Just like the origin of the human race is biblically Adam and Eve, right? That's where everything began. That's where everything started. And so with this city, the plan is that the origin is at the U.S. Capitol. So everything is focused around the U.S. Capitol. All of the streets, if you look at all of the street names, everything is based off of the U.S. Capitol being the origin. So that's really important to understand. Then you have the vertical axes and the horizontal axes. The vertical axes, that is your y-axis. So you have, these are your vertical, and your x-axis is your horizontal. Okay, so understand that when we're talking about vertical and horizontal axes, that is your y and x axes there. And we do the 4 quadrants again. You have quadrant 1, which is your northeast. Quadrant 2 is your northwest. And then you would have your southwest and southeast as your 4th quadrant. So those are your directions in this case. So you should be able to describe the locations of some of these landmarks as well. And we're going to work on that, from the U.S. Capitol. How do you get to Union Station? And it seems pretty straightforward. So Euclid, a famous mathematician who's known for writing his works on Euclid's elements, uses this idea of streets and the U.S. Capitol of the origin to explain some of his understandings in geometrical shapes. So that's what we're going to study in using streets like this. So in this investigation, we're going to be describing locations using these coordinates, right? So like the coordinate 2, 4 would be from the origin, you come to the right 2 or east 2, and then up or to the north 4, and then you are there. All right, so get used to identifying points or areas on our graphs by using coordinates. A lot of times it'll be blocks, like with these streets, it's going to be this many blocks east, this many blocks north, and so forth. All right, so make sure that you are proficient in those ways. So let's say we have the city of Euclid. And everybody who found this city of Euclid absolutely loved math. In fact, they named their city after this famous mathematician, Euclid, that we've talked about. Right? So then they're going to explain or describe where different parts of the city are by using coordinates. And that's what we're going to do. And one of the big questions that we're going to talk about and answer in some of these problems is, how do we compare driving to flying distance? All right, so first thing I want you to do on part A right here is go ahead and give the coordinates of each landmark in the map above. And you should also have a lab sheet for this, which looks like this. So you can go ahead and use this lab sheet, and you can draw on this as much as you want to figure out what those answers are. So if you go ahead and check your answers on all of these, the gas station's at 4.4, stadium's at -2.3, greenhouse at -6.0, hospital at -4, -6, -4, police station, cemetery, and animal shelter, and the art museum. So go ahead and check your answer on all of these to make sure that they're accurate. And now go ahead and answer part B, where it says Euclid's chief of police is planning emergency route. She needs to find the shortest route between the following pairs of locations. So you're going from the police station to City Hall, police station to City Hall, hospital to City Hall, hospital to the art museum. And you're trying to find the shortest routes to each of those. And give precise directions, meaning this many blocks north, this many blocks east, and so forth. And then also find the total distance. So maybe one would take 11 blocks, the next one would take 7 blocks. Just add those together. So if you go 4 blocks north and 5 blocks east, that's a total of 9 blocks that you're going to have to travel. All right, go ahead and answer part B and then come back to the video. Okay, so for the first one, to go from the police station to City Hall, it's just 1, 2, 3, 4 blocks north. And so you would say 4 blocks north for police station to City Hall. And there are 2 different ways. If you're going from the hospital to City Hall, you could go north and then east. So it would be north 1, 2, 3, 4 blocks. And then east 1, 2, 3, 4, 5, 6 blocks. Okay, so that's hospital to City Hall. And then if you're going hospital to the art museum, you could go again north and east, but let's go the other way. We're going to go east over to here, and then we're going to go north to there. So we go east 6 and 6, which is 12, so east 12 blocks. And then we go north 4 and 1, which is 5, so north 5 blocks. Okay, and then the other part of the question says, hey, how many total blocks are there? So if we look at these, so let's answer this one first, since I have this color pen on. That's 12 plus 5, that's 17 blocks. And then if we look at this next one here, that is a total of 10 blocks. And then this one is easy. This is just 4 blocks because it's a straight shot. So part C says the stadium is at -2.3. That's on our map. And now you have to think about the high school being at 1.8. What's the shortest driving distance in blocks between those 2 locations? So try to do this without looking at the grid. So think about from these coordinates to these coordinates, how far in a horizontal direction. So the horizontal direction would take into account those x's. And what's my vertical change? And that would be your y's. Right, and then try to explain your answer. And then number 2, suppose you know the coordinates of 2 landmarks in Euclid. How can you determine the shortest driving distance in blocks? Right, so go ahead and try to answer both 1 and 2, and then come back to the video to see how you did. Okay, so if we look, and where this should sound familiar, we're finding the horizontal change and the vertical change, right? So the horizontal change in this case is your east-west change or west-east, depending on what point you're going from. But since we're going from the stadium to the school, it would be an a west to east change. But I just went -2, -1 to find the difference, to find the total change. And so that's right here. That gave me -3, but we're looking at distance on a map, and that is never a negative. Distance is never a negative. We learned last year that that's the same thing as the absolute value. So if we want the distance, that's like asking to find the absolute value, and that's never negative. So our answer absolutely needs to be a positive answer because we're looking at the total distance or change. Same thing with south to north or north to south, right? I take 3 minus 8, and that gives me a change of -5, or since we're looking at the absolute value, that needs to be a +5 right there. And so in part 2, it's basically doing what we did, but putting it into words. And that transition is really important. I know that it's difficult. Writing mathematical sentences is difficult, but it's really important because it helps you understand what you did, right? And so to answer number 2, I want you to say something about finding the horizontal change. That's the east-west change. And that is the shortest distance east-west to get to that point. And then also applying the north-south change. That's your vertical change. And that will give you the shortest distance, the way that a car can drive, and northwest vertical change. Right, so you find the horizontal change in the coordinates by subtracting your x's, and then you find the vertical change by subtracting your y's, and since it's distance, no matter what your answer is, it's always going to be positive. Go ahead and pause the video, digest that a little bit, and answer part 2. And then in D, it says a helicopter can travel directly from one point to another. So that's bypassing those street systems. So for each question, pair in part B, so we're coming back up to B. Find the approximate distance in blocks a helicopter would have to travel to get from the starting location to the ending location. So you could use a centimeter ruler if you wanted to, that's fine. But let's look. So the first one was from the police station, which we did this in red, from the police station to City Hall. Now, if a helicopter went, it would be exactly the same as we were in a car. Now, if you look at the next one, hospital to City Hall, a helicopter would be different because they don't have to travel north and then east. They can just go northeast right there, right? So this distance is going to be different. So do we think it's going to be the same? Do we think it's going to be less than? Do we think it's going to be more than? That's kind of what you're trying to figure out. So if you wanted to go ahead and take a ruler, measure that. Take a ruler and measure then this distance from here and here, add those together and see what happens. And so for this one, this should be about 7.2 blocks, depending on if you use a centimeter ruler, inch ruler, but it should be with this graph, it should be about 7.2 blocks. And then if you did the same thing for the last one, where we went from the hospital over and up, a helicopter right here is going to go 13 blocks. And so you can look, 13 blocks is less than 17, and then also 7.2 blocks is less than 10. So it's going to be less for those, but equal to the one from the police station to City Hall. And then explain why. Why do you think that's going to be? Go ahead and pause the video and try to do that. And the reason is because you look at the police from the police station. So right here, from the police station to City Hall, that's a straight shot. But if you're looking at these other two, the way the hospital, or sorry, the helicopter goes is a straight shot, but the car cannot go directly from one point to another. So that goes back to the old saying, the fastest way between 2 points is a straight line, and that's exactly what we have going on here. So go ahead and answer that question in your own terms. On number 2, it says, will a direct helicopter route between two locations always be shorter? And that answer is going to, sometimes it will be, but explain why and in what cases it would be, and why and in what cases it would not be. And we've already talked about that. So on this video on 1.1 driving around Euclid, and that is all that I have.